Welcome back to Precalculus, everybody. Today we're in Chapter 3, Section 7, talking about polynomial and rational inequalities, where we've been doing equalities the whole chapter. Okay, so this is the last section of the chapter. We're closing it out with inequalities. Okay, so quick reminder about quadratic. So when solving a quadratic inequality, it requires that first we locate any real zeros. Emphasis on real. We don't care about the imaginary ones because they're not on a number line. Okay, and then we need to determine if the graph opens up or down. Okay. And also, just a quick note: if there's no x-intercepts, then the graph is either entirely above or entirely below the x-axis. That's going to be important to understand. So let's take a look here at this first inequality. So we're trying to figure out where is this inequality less than or equal to 0. So let's go ahead and rewrite it. And what I'm going to do first here is I'm going to go ahead and just divide everything by a -1, because 0 divided by -1 is still 0, and it's going to get that negative off the front of my polynomial, but it's going to change it to -x minus 20. Okay, now factoring that should be super easy. X minus 5, x plus 4, with our zeros being at 5 and -4. Okay, zeros being at 5 and -4. So what we need to understand is, looking at this original quadratic, it's got a negative leading coefficient, so it opens down. Our quadratic essentially looks like this. I'll draw it real light here. It looks like that. Okay, so we're being asked, where is our function less than or equal to 0? Where is this function less than or equal to 0? Well, obviously everywhere to the left of -4. So negative infinity to -4 inclusive, because we're talking about less than or equal to. And then it's underneath the x-axis again, everywhere from 5 to infinity. Okay, let's dive into another one here. So this one's got variables flying all over the place. You know, basic algebra 1 stuff, move everything over to one side. So we're going to say x squared. I'm going to add my x over, so that'll become 4x. And I'm going to add 7 over. That's going to become plus 4 is greater than 0. And if we factor this perfect square trinomial really quick, you should understand that it is x plus 2 quantity squared is greater than 0. So you can see that this quadratic here, this x squared plus 4x plus 4, actually only has one 0 at -2. And it should make sense that, hey, the multiplicity is 2, so it's going to bounce off that 0. And it's got a positive leading coefficient, so it's going to open up. It's going to look like that. Okay, now we want to know, where is it greater than 0? So we actually don't want to include this point. So we want to know, where is this graph above the x-axis? Strictly above the x-axis, not on it, but above it. So anywhere to the left of -2, so negative infinity to -2, non-inclusive. And then everywhere to the right, -2 to infinity. Okay, let's keep on moving here. So the next one, we want to know, where is this function, this polynomial, this quadratic less than 0. So let's write it out. 24x squared minus 30x minus 9. So the first thing I'm going to do is divide everything by 3. Everything happens to be divisible by 3, and 0 divided by 3 is still 0. So this is going to become 8x squared minus 10x minus 3. Now this is an AC method one, so we got to multiply 8 times -3, and we're going to get -24. So what factors of -24 add up to be -10? It's going to be -12x plus 2x. And then we're going to group. So if we group, we can pull out a 4x leaves us with 2x minus 3. We can pull out a 1, which leaves us with 2x minus 3. So now we can pull out a 2x minus 3, and it leaves us with a 4x plus 1, which we can now use to see our zeros very easily. So we have a 0 at 3/2 from this factor, and a 0 at negative 1/4. We have a polynomial that's essentially opening up, a quadratic that's opening up, so it looks like this. We want to know where is it less than 0, strictly less than 0, so we don't want to include the zeros. And that's real easy. It's less than 0 right here between negative 1/4 and 3/2. Awesome. Okay, so let's take a look here at this next one. It's going to be relatively short. I'm just going to move everything over to one side and do it down here underneath my work. So I'm going to end up with x squared plus 9 is greater than 0. So if I solve that right now, it's real simple. I'm going to get plus or minus 3i. I'm going to get x is greater than plus or minus 3i. We don't care about that, okay, because that's not on the real number line. We don't care about those zeros because they aren't technically x-intercepts. But if you think about it, what's happening here? This is a quadratic opening up. It's a parabola opening upwards. Shifted up 9. It's not going to intercept our x-axis. Our parabola is going to look something like that. So you're asking, where is this parabola greater than 0? Simple. Everywhere. Negative infinity to infinity. Awesome. Okay, so let's take a look at this last one on the page here. So again, moving everything over to the other side. So we're going to say x squared. We're going to subtract our x. It's going to be minus 6x minus 5 less than or equal to 0. Well, there are no factors of negative 5 that add up to be negative 6. So we're going to have to use your quadratic formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. And when you do that, you should be getting 6.74 as an answer, or negative 0.74. So we have an upward facing parabola with these two x-intercepts. So let's go ahead and draw them. Negative 0.74 is about right here. 6.74 is about right here. We have an upward facing parabola. And we do want to include our x-intercepts. And we're being asked, where is this parabola less than or equal to 0? Well, simple. Where is it under the x-axis? Right here, between negative 0.74 and 6.74. Okay, let's dive into some more difficult ones and do some higher degree polynomials. So first thing we have to remember is when solving polynomials, we got to write f in completely factored form. Got to factor everything. Okay, we need to plot the zeros on the x-axis, noting their multiplicity. Remember, if the multiplicity is odd, the function will change signs. It will cross the x-axis. It'll go from positive to negative or negative to positive. And if the multiplicity is even, it's going to bounce. There will be no change in sign. It'll either bounce and stay positive or bounce and stay negative. So lastly, we're going to use the end behavior to determine the sign of f in the outermost intervals, and then we're going to go from there, okay, by analyzing the multiplicity of the neighboring zeros. Okay, so what we're going to do here is you guys are actually going to do this first one on your own after I do this one. Okay, so it's going to be about the same process, but I want you guys to note that you're going to be doing that first one on your own. So first things first, we got to factor this whole thing. And I want to check to see if 1 is a 0. So let's add up all of our coefficients. 1 plus 5 is 6, plus 1 is 7, plus negative 21 is negative 4. Nope, we're not going to get 0. So 1 is not a 0. But we can go ahead and change the odd degree terms. The sign on the odd degree terms, that one will become negative. This one will become positive. And let's see if we add up to 0, because then negative 1 might be a 0. So here we go. 1 plus negative 5 is negative 4, plus 1 is negative 3, plus 21 is 18. So negative 18 is 0. So we know negative 1 is a 0. We're going to go ahead and do synthetic division with negative 1. Here we go. 1, negative 1, 4, negative 4, negative 3, 3, negative 18, 18, 0. Beautiful. 0 remainder. It's exactly what we wanted. Okay, now looking at this polynomial here, this would be 1x cubed plus 4x squared minus 3x minus 18. Okay. If we add up all these coefficients, clearly 1 is not a 0 of this polynomial either. We already knew negative 1 was a 0 here. I don't think if we change this one and this one, negative 1, be 3, 6. No, negative 1 is not another 0. Okay, so we need to look at the rational root theorem and determine what factors of this divided by factors of this, which is easy because it's 1. Okay, what factors of this divided by this could possibly be zeros. So I encourage you to pause your video and try some zeros out. Try some possible synthetic division on this right here. Okay, using factors of 18 over 1. So maybe try 2 over 1, 3 over 1, 6 over 1, 9 over 1, 18 over 1, a negative version. You may find something. Okay, but pause your video for a second and see if you can figure it out. Okay, so after some trial and error, I've decided that I'm going to go with 2. 2 is a factor of 18, 2 over 1. Okay, so let's try it out. So 2, 6, 12, 9, 18, 0. Beautiful, another 0 remainder. So now I know I have 2 zeros, and I've broken this 4th degree polynomial down to a quadratic. So I know that I have x plus 1 as a factor, because that negative 1 was a 0. I've got x minus 2 as a factor. And I've got this x squared plus 6x plus 9 left over, which is a perfect square trinomial. So I can rewrite it as x plus 1 times x minus 2 times x plus 3 squared. It's real easy to see our zeros now. It's real easy to see where this is less than or equal to 0. Okay, so let's go ahead and draw a number line. And let's plot them. So we've got negative 3 is a 0, negative 1 is a 0, and 2 is a 0. Okay, notice we have a multiplicity of 2 on this 0 because it's 4th degree polynomial. Makes sense. 1 plus 1 plus 2 is 4th degree polynomial. Okay, so because it's a 4th degree polynomial opening up, I know that over here it's going to be positive. I know that over here it has to be positive. Because if I was to draw our polynomial, it would look something like this. Okay, so let's take a look at the zeros. So at negative 3 is multiplicity 2. It should bounce right there. Okay, so our graph, if it's positive, it should stay positive on the other side, which I'll draw a picture of it here in a second. That'll make sense. At negative 1, negative 1's multiplicity is odd, so it should be crossed. So if it's positive, it should be negative. And then let's just check 2. 2 has a multiplicity odd, so it should be crossing. So if it's negative right here, it should be positive on the other side. So if we were to draw this polynomial, it would look something like this. It would bounce there, cross, kind of airballed, at negative 1, and then it's going to cross again at 2. So we're being asked, where is this graph less than or equal to 0? Now, it's real. People see the obvious one, between negative 1 and 2. You are correct. negative 1 and 2. But we're being asked where is it less than or equal to. So we want to include all these points. And right here at negative 3, we are equal to 0. So we can't forget about the number, just negative 3 is where we are also equal to 0. Awesome. So take a moment, pause your video. I want you guys to try this one on your own. Okay, a third degree polynomial, find all zeros, draw your number line, do your bouncing and crossing, see if you can figure out where it is going to end up being greater than 0, because you're going to move everything over. Okay, pause your video. Okay, now let's try the same exact process, but let's do it with a rational inequality. Okay, a rational inequality. So let's take a look at this first example here. All right, remember we got to try and factor everything first. So the top is going to be an easy factor. That's going to factor into x minus 4, x plus 3. And the bottom looks like we need to group. So let's get our group on here. And let's pull out an x squared. It's going to leave us with an x plus 2. And let's pull out a negative 4, which is going to leave us with an x plus 2. So what that's going to give us, the top's going to stay the same, x minus 4, x plus 3. The bottom is going to be, we pull out an x plus 2, and we're left with an x squared minus 4. Awesome. Now we do know that this x squared minus 4 factors into x plus 2, x minus 2. Difference of squares always factors into binomial conjugates. So I'm going to simplify the bottom just a little bit more. The top is going to stay the same. And the bottom is going to become the quantity x plus 2 squared times x minus 2. We want to know where is that greater than or equal to 0. Okay, so let's draw our number line. Now we know that setting the numerator equal to 0 gives us our x-intercepts. So at 4, we're going to have an x-intercept. At negative 3, we're going to have another x-intercept. At negative 2, we set the bottom equal to 0 to find vertical asymptotes. So at negative 2, you will have a vertical asymptote. And at 2, you will also have a vertical asymptote. Okay, we've been graphing rational functions for a few days now. Okay, so now we need to figure out what is happening. All right, so the easiest thing to do is just plug in a point. Plug in a really simple point and see if it's positive or negative, and then examine your multiplicities from there. Okay, so I see that right in here between negative 2 and 2, I have the point 0. It's about right there. Let's just plug 0 into our function. All the x's will be gone. I'll end up with negative 12 over negative 8, which is 12 over 8, which is positive. So I know in this interval my function's positive. So now let's look at everything. Let's look at this asymptote 2. 2 has a multiplicity of 1. So it should technically quote unquote cross and change signs. So on the other side of 2, it's going to be negative. Now let's look at the multiplicity of this x-intercept, 4. Also 1. So it should change signs again, back to positive. Okay, now let's go over here. Let's look at negative 2. Negative 2 has a multiplicity that's even. So we should be bouncing. So if it's positive on that side of negative 2, it better be positive on this side of negative 2. And then our last one, negative 3, right here, has a multiplicity that is odd. So we better have a sign change because it's going to cross right there. Okay, we're being asked where is it greater than or equal to 0. So where are our plus signs at? So from negative 3 to negative 2. We don't include negative 2 because that's a vertical asymptote. It's also positive between negative 2 and 2, those two vertical asymptotes. And then here from 4 to infinity. Okay, so you can use multiplicities and everything to kind of see where this thing's sign changes. All right, so if you were to graph this thing, it's going to look a little bit something like, okay, we know we have a horizontal asymptote at y equals 0. All right, lights went out. Okay, I can give you a quick sketch of this. So if you're graphing this rational function, it would look something like this. It would stay positive here. The horizontal asymptote would be on the x-axis. It's going to be negative here and then positive, so it's going to bend back towards the horizontal asymptote. And similar thing here is it's going to here, it's going to cross and then bend back towards the horizontal asymptote, in case you're curious about what that would look like. So anyways, pause your video and give this one a shot. See if you guys can figure out where this rational inequality is less than or equal to 0. Okay, last part. So these tests can all be done by something called the interval test. You're just essentially testing values in intervals to see if it's positive or negative. It makes you not have to know anything about asymptotes or multiplicity. Okay, so let's talk about it. An interval test method can be used to solve any polynomial inequalities as an alternative to what we just did. Okay, so the x-intercepts and vertical asymptotes are noted on the x-axis, and then a test number is chosen from in each interval, and that'll give you whether it's positive or negative in that interval. Okay, so let's take a look here at this rational inequality. So first things first, let's move everything over. So x plus 6 over x minus 6 minus 1 over x has to be less than or equal to 0. Looks a little ugly, but let's just make it look like the last couple examples we just did and combine these two and make one fraction. So what we're going to need to do is we're going to need to multiply this top by x and this bottom by x, and this top by x minus 6 and this bottom by x minus 6. And that'll give us common denominators. Okay, so the top on the left is going to be x squared plus 6x. On the right side, negative 1 times x is going to be negative x. Negative 1 times negative 6 is going to be positive 6. And our denominator is going to be x times x minus 6. Okay, so we can simplify that top, and that's going to become x squared plus 5x plus 6 over x times x minus 6. Which I'm going to think we can factor that. So let's go ahead and factor it. It's going to factor into x plus 3, x plus 2 over x times x minus 6. Okay, so bottom line, set the top equal to 0 to find your x-intercepts. So negative 3 and negative 2, those are going to be x-intercepts. 0, x equal to 0, is going to be a vertical asymptote. And 6 is also going to be a vertical asymptote. So we have a bunch of intervals that we can test. Okay, so essentially you're just picking random numbers. Doesn't matter which one. You can pick any numbers you want. And then you plug them into your polynomial and see if you get a positive number or a negative number out. So any number to the left of negative 3, you could test negative 4. If you do that, you're going to get a positive number. In this interval, you could test f of negative 2.5. If you do that, you're going to get a negative number. And maybe over here in this interval, you test f of negative 1. If you do, you're going to get a positive number. Just plug them in. That's all I'm doing here. I know I'm doing the mental math on the side here, but all I'm doing is plugging these values into this polynomial and seeing what the answer is. Okay. Between 0 and 6, maybe 1 is an easy number to choose. So if I plug in f of 1, I'm going to get out a negative number. And if I plug in, I don't know, f of 10, then I should get a positive number. Now, if you know anything about multiplicities, you know that all the multiplicities are odd, so we should always be having a sign change. Okay, so you really could just test one interval. Okay, maybe you test -4, you get positive, and then you know it's going to sign change every other one after that. So figuring out where it's less than or equal to 0, basically where's our negative signs? Here, between -3 and -2. And here's another negative sign here between 0 and 6. Awesome. So what I want you guys to do is the same process here with this polynomial. So you're going to have to factor the polynomial all the way. Remember to check 1 and -1. You know, maybe both of them will be zeros, but do a bunch of synthetic division. Okay. Break it all the way down and do the interval test method on all those x-intercepts to see where is it greater than or equal to 0. And we can answer questions in class. Have a great day.